Good evening guys, what's up? Welcome to my new demonstration video. Myself Madan Patel. So we have this is my demonstration video about about our project. We have did an internship in Emertxe technologies, an embedded system with the PIC 16F877A microcontroller, and we have developed a project of automatic washing machine. And these are the contents. Mm, First, we'll first we what these are contents are what we have learned in the internship, such that basics of we have learned about a basic C language, and where we can where we are using in our daily life, where the C languages are we are using, and introduction to embedded systems and the categories of embedded system. Problem statement of this problem statement is about our project, and what are the softwares we are used during the internship, and the architecture about PIC 16 F877A, and CLCD keypad, tactile switches, ISR, fan, buzzer, timers, outputs. Next is let's see basics of our C language. Guys, as we know that the C language is a general purpose language, and it is free formatted also, and as we know that it is very easy to use, and it is a mother of all languages. We use the C languages in embedded software development, system software development, OS kernel development, firmware, middleware, and driver development, file system development, and we use in many more also. And coming to an introduction, we see about what is an embedded system. As we know that an embedded system, in embedded system, it has a it's a microprocessor based computer hardware system with software that is designed to perform a dedicated function either as an independent system or as an a part or part large part system. Okay, sorry, large part system. And let's see what's an Emertxe. Emertxe is an popular programming language which is basics of C programming language only. It is this Emertxe language is used to develop an electronic gadgets. These are the categories of embedded systems, and in these categories we come about okay, sorry, uh, standalone embedded system. In this standalone embedded system, we have a slave means semi-automated and independent embedded systems. And after we have real-time embedded systems, networked embedded systems, mobile embedded systems, and hybrid embedded systems. Looking on to the problem statement. In these days, what we have is we are using washing machine, and we are dependent on AI and etc etc etc. But to make an daily life easy, we are developing an automatic washing machine using uh, PIC 16 F87877A microcontroller. We have tried it. Let's see. These are all the softwares are we are using, that is MPLab XD version 5.50, and we are using XE8 compiler to compile the programs, etc. And we are using PiximLab.
to the block diagram of the embedded system. This is the block diagram of the embedded system. A three-layer model consisting of hardware, software, and applications. The hardware layer consisting of physical components like processor, input, output devices, and memory. The software layer includes the operation systems, drivers, and middleware. The system bus carries address, data, and control buses. It is comprised of three types of buses to do this function: the address bus, the data bus, and the control bus. Microcontroller is a control device which incorporates a microprocessor. A typical microprocessor includes a processor, memory, input and output, and peripheral devices on a single chip. Future scope in embedded system. Embedded system is the future. Every industry needs some artificial intelligence into it, and artificial intelligence can be given by embedded systems only. No electronic product is without embedded system in the market. And who is going to develop future embedded systems? According to a survey, embedded system industry will reach $360 billion by the end of 2020. Jobs in embedded industry will reach to 12 lakh by 2020. Companies like TSC, Wipro, L&T, Tata, Infosys and Zenza and Tech Mahindra, like many, are investing heavily in embedded systems in operations of India. Mobile manufacturers like Foxconn are setting up their plant in India. Experts say what IT was in 90s is where embedded system stands now and ready to explode. The main sectors of embedded systems are transportation, medical, industrial, energy, military and security, and like many more. Embedded C. Embedded C is most popular programming language in software field for developing electronic gadgets. Each processor used in electronic system is associated with embedded software. Embedded C programming plays a key role in performing specific function by the processor. In day-to-day life, we used many electronic devices such as mobile phone, washing machine, digital camera, etc. These all devices working is based on microcontroller that are performed by embedded C. And the main example of embedded system is washing machine. The washing machine is made with the help of some sensors, motors, water pump and etc. And next move on to the main problem faced by the implementation of the washing machine is to develop a washing machine interface and emulate it, which displays and allows user to select different types of washing machine on pressing digital keypads and water levels on long press. On starting machine, it should display function running and remaining time, and it should stop when the lid is open. The three softwares which are used in this internship is MPLAB X IDE, Microchip Technology. MPLAB X Integrated Development Environment is an expandable, highly configurable software that incorporates powerful tools to enable designer to discover, configure, develop, debug and qualify embedded design for most microchip, microcontroller and digital signals. And next is XCB compiler. Microchip technology MPLAB XC compiler generates highly optimized code for the microchip, 8-bit, 16-bit and 32-bit PIC microcontrollers and DSPIC digital signal controllers. Designer can choose between free, standard and pro editions. PiximLab. PiximLab is a real-time emulator of development board with MPLAB X or AVR GDB debugger integration. PiximLab support microcontroller from Pixim, SimAVR, UCSim, QEMU STM32, QEMU ESP32 and Gypsum. PiximLab has integration with MPLABX or Arduino IDE for programming the microcontroller boards. PiximLab PixGenius. This is what. And next is PIC16F877A, Pixenius board from Microchip. In this internship, we used PIX16F877A microcontroller. Bus width with 8 bits, pin count. It has total number of 40 pins and there are 33 pins for input and output. Program memory 14.3 kilobytes. CPU speed 5 million instructions per second. RAM size 368 bytes. EEPROM size is 256 bytes. The architecture of the PIC16F877A is PIC16F877A is based on modified hardware architecture, featuring both program memory and data memory spaces. It has 14-bit instruction words, providing a good balance between complexity and simplicity. The architecture includes a variety of registers, making it versatile for different applications. Next is CLCD, Character Liquid Crystal Display. Alphanumeric LCD display module means it can display alphabets and numbers. Consisting of 4 rows, each row can print up to 16 characters, can work on both 8-bit and 4-bit mode. D0 to D7 are the data transfer lines and register select. The pin number 4 register select, 0 for instruction register and 1 for data register. Enable pin and read or write select pin. Keypad. Keypads are used to give input by the user in binary format. They consist of push button. They can be triggered in two different ways. Level triggered and edge trigger. Level trigger means activated when the voltage is on high level, and edge trigger is activated when the voltage is suddenly changed. They can be in two different configurations, sourcing circuit and sinking circuit. When the input is 1, the switch is on. When the input is 0, it is off, and in sinking circuit, when we give 1, it's off and 0 on. Tactile switches. When we press a push button or the switch is on. When the input is 0, it is off, and in sinking circuit, when we give 1, it's off and 0 on. Tactile switches. When we press a push button or toggle switch or a micro switch, two metal parts come into contact to short the supply, but they don't connect instantly. The metal part connect and disconnect several times before the actual stable connection is made. An array of tactile switches from the digital keypads. ISR, FAM, buzzer. These are important. ISR, interrupt service routine. An interrupt service routine is a software routine that hardware involves in response to an interrupt. ISR examines an interrupt and determines how to handle it, execute the handling, and returns a logical interrupt value. This is ISR vector table and main programming flow, interrupt service routine. See, from this figure we can understand that ISR main program flow, interrupt service routine. The interrupt is entering into the main programming flow. Fan. On the board, the passive cooling fan are mostly used in all desktop computing and embedded systems. This is the fan. And the buzzer. In the embedded system, buzzer is widely used to notify various events such as interrupt generation and end of program, and in emergency situations like detection of fires. Next is timer. Timer is nothing but a simple binary counter that can be configured to count clock pulse. Once it reaches the max value, it will roll back to 0, setting up an overflow flag and generates The interrupt generates the interrupt enabled. PIC 16FA77A has 3 independent timers.
This is a video of our project demonstration. In the first step, we have to turn on the washing machine by pressing the key 5. Here RB5, RB4 sorry. After this the washing machine will be powered on. The washing programs are here, so daily, heavy, delicates. Eco cotton, stain wash, bedsheet, and so on. By pressing the key for RB3, we can change those. Here we will select the delicate option. For selecting the same, we have to press the key for RB3 here for a long time. After selecting a washing program, we have to select the water level now. For selecting the same, we have to press the RB3 key 4. These are the water levels: auto, low, medium, high, max. We will select the low water level by pressing the key 5, key 4, RB3. I will get the interface of start and stop. If I want to start the washing machine, I have to go with the switch RB4, the key 5. Otherwise, to stop, I will press key 6. After pressing the key 5, I will switch on the washing machine. The program delegates here will show. The function time is shown and start and stop. You can pause the washing machine by pressing key 6. We can also check by pressing key 6 the machine is paused. The timer is also paused. Once the washing machine will be started, at this time the door is open or not. This condition can be checked by pressing the key RB0. Here you can see the fan is now closed. See this, the washing machine will start. CLCD also stop after completing the program. Thank you.